In this video, we'll talk about the difference of two squares. Something that you will need for those exercises is the third binomial formula. I hope you all remember it. If not, I will write it down here on the top. It's x plus y times x minus y is equal to x squared minus y squared. So as I said in the video about the binomial formulas, knowing the formulas is not that hard, but you need to be able to recognize when to use it and which one to use. So for example, here in this first exercise, this might not look exactly like the binomial formula, but if you open your eyes and you can see the 9 is actually the same as 3 squared, you can rewrite this expression as 3x all squared minus 1, which is 1 squared. And then that's the same as, now I use the formula right here, 3x minus 1 times 3x plus 1. And it doesn't matter if you put the minus in the first parentheses and the plus in the second, or the opposite way. It's exactly the same because you can change the order of a product. Alright, let's go to the next exercise, which is 4n squared minus 49. Now again, 4 is the same as 2 squared, so 2n all squared minus, and 49 is the same as 7 squared. And you can simplify this to 2n minus 7 times 2n plus 7. And you can pause this video at any time and just try to do these exercises by yourself, and then just check back for the answers. Or if you get stuck, just watch this video. So 36k squared minus 1. Same here, 36 is just 6 squared. So we can rewrite it like this. Minus 1 squared. That's equal to 6k minus 1 times 6k plus 1. Now the fourth exercise, p squared minus 36. Rewrite it as p squared minus 6 squared, and that's equal to p minus 6 times p plus 6. Alright. Number 5. 2x squared minus 18. Now this is a little bit more difficult just because you don't have the squares already given to you. So here's a 2, that's not a square or a perfect square, and 18 is also not a perfect square. But what you can notice is that 18 is also divisible by 2. So what you can do here is just factor out the 2. You're left with x squared minus 9. And 9 is a perfect square, which is just 3 squared. So that's the same as x squared minus 3 squared. Now here we can use the binomial formula again, which gives us 2 times x minus 3 times x plus 3. And that's the final answer. Alright, let's do number 6. 196 n squared minus 144. Now this one is a little bit harder because you have to know your perfect squares. So if you look at 196, you might think, well, how can I calculate this number? But actually 196 is just 14 squared, which is something that will help you if you know that by heart. So the best way is just to learn all the numbers up to 25, and their squares. Squared. So we can rewrite it as 14n minus 12 times 14n plus 12. Alright. Let's go slightly down so we have a bit more space. And I'll write the formula again. X minus y, x plus y equal to x squared minus y squared. Okay, so number 7 is 180 m squared minus 5. Again, 5 is not a perfect square, but what we can do is just divide 180 by 5. If you want, you can use a calculator for that. Let's take 5 out, and that will be 5 times 36 m squared minus 1 equal to 5 times 6m squared minus 1 squared. So that's 5 times 6m minus 1 times 6m plus 1. That's your final answer. On number 8, 294 r squared minus 150. Now for this one, we can also factor out some numbers. So if you don't really know which number to start with, for example, the 150, that's definitely divisible by 3. So I would just try to divide 294 by 3. You can also use a calculator for that. And that's 98. So 3 times 98 r squared minus 50 all squared. Now, oh, no, not all squared. Sorry. Like this. Now that's still not a perfect square, the 50, and the 98 isn't either. So we'll try to factor out another prime number. So for example, the 2. Try the 2. So in the front we'll have 6, and 98 divided by 2 is just 49, and that is a perfect square now. I hope you recognize it. Minus 25. That's the same as 6, and 49 is just 7 squared minus 5 squared. And we can rewrite it as a difference of two squares. Minus 5 times 7r plus 5. And that's the final answer. Alright, just 4 more to go. Number 9, 150k squared minus 216. We'll do the same trick here. Try the 3 and the 2. So that's 350k squared. You can also use a calculator for this again. To calculate 216 divided by 3, it's not that easy doing it in your head. And that's also still not a perfect square, so we'll try to divide it by 2 as well. So we'll have the 3 times 2, 6 in the front. And now 25k squared minus 36, and those are both perfect squares. So we can rewrite it as 5k all squared minus 6 squared. And that's 6 times 5k minus 6 times 5k k plus 6. That's your final answer. Alright, let's do number 10. 20a squared minus 45. Now let's take out a 5. That will give us 4a squared minus 9. We have two perfect squares again, which is 2 squared and 3 squared over here. And we can write it like this. 2a plus 3. That's the final answer. Alright, let's continue over here. Have a little bit more space. 3n squared minus 75, and again 3 is not a perfect square, so let's take it out. N squared, 75 divided by 3 is 25, which is a perfect square. And we can rewrite this parentheses as n minus 5 times n plus 5. And that's it. Last one, 12. And now we have x cubed. But don't let that throw you off, because x cubed is not a perfect square. We can factor out the squared, the x, sorry. Factor out the x, 24x squared minus 54, and that's still not a perfect square. So we'll keep going over here. Maybe just divide this by 2, take the 2, write it in front of the parentheses. 12x squared minus 27. Still not a perfect square, but we can divide 27 by 3. So we'll be left with 6x. Let's take the 3 to the front. It's 4x squared minus 9. And that is a perfect square now. So we have x times 2x all squared minus 3 squared. And rewrite this as 6x and then 2x minus 3 times 2x plus 3. And that's it. That's it for the video. Some practice for completing the difference of two squares.